celebrities and bands and stuff like that, and it goes up online. That's part of what Gosh TV is, but there's more to Gosh TV. Pardon me, our company, huh? I have my own heckler. Our company is Gosh TV, and we are a, my brain just went. We're a media technology company, and what that means is we do everything having to do with media, internet, online, video, audio, editing, everything, as well as we design stuff. People come to us to either help them design TV shows, or help them with either games or the back end of games, which is what Robin will be talking about.
Servers.
So we also have stuff that have articles that go up at Hollywood Daily Star and other publications online. I also actually write for a print newspaper called British Weekly. I do book articles for them.
The number one British newspaper in America, actually.
Yeah. Ooh, he took my slide away. I guess I turned it over to him.
Well, no, you mentioned everything, so we're going to segue when you're ready.
Okay. Somebody came to, I said to Robin for years, we need to be doing stuff with games, because that is where it's at. Everyone has a phone, everyone has a computer, a tablet. They're doing a lot of stuff with games. I actually play a lot of games. And I said, we need to do this. And then all of a sudden somebody came to us, like within 2 weeks of my saying that, somebody came to us and said, we need help with game server.
They had 150,000 lines of Java as their game server.
Yeah. Yes, that's exactly the reaction. Ooh, no! And so they came in and we chatted with them, and they realized that what they were doing wasn't going to work with how they wanted the game to be played, because it's actually, can I say what it is?
I don't know, can you?
Okay, well I wasn't sure. Sometimes I'm not sure because we've signed stuff and
Well, we're not naming any brands.
Okay, it's a poker game. And poker means a lot of people play at once. Now in the States there's a little bit of difference in who can and cannot play. In fact, it used to be no one in the States could really play electronic
For money games.
For money. Poker games or bingo or anything like that. They just, in the last week in fact, was it New Jersey just approved it?
Yeah, New Jersey just came online, Delaware.
And Delaware came online, I think back in April. So they're just starting to get into it because they realize they can make money that way. And the government's beginning to loosen its hold. About 6 years ago, they turned it off, saying no gambling online whatsoever. And I think they were really afraid of the fraud issue. But then they realized they were losing money. So now it's slowly turning back on. It's going state by state now.
So shall we talk about the tech?
Okay, let's talk about tech.
Okay, so when you're building games, the thing that you run into right away is how many sockets you need. You think, well, you know what, we just use UDP and we get connectionless and whatnot, but then you get into an authentication problem of how do you know that is still the same player that connected in the first place. So the strategy that everyone uses is that it's one socket per player and you keep the connection open. So then it's like, well, okay, but what about C10K, where most servers are designed to top out at about 10,000 simultaneous connections, and that's not economic. You can't, you need a whole, here's the Facebook server firm. They're serving 900 million plus users. Racking up all those computers costs money. If you've got billions, that's fine. But even if you do, you probably don't want to rack up any more computers than you have to. So the challenge becomes how many sockets can we cram open on one computer and not have it fall over. And 100,000 plus is what people generally expect these days. And there are tweaks that you can do to Linux and FreeBSD to make the kernel have large enough socket tables and stuff like that. But there's also design considerations that come into it. When you get into these massively multiplayer servers, that with that many players on the machine, you need to try to conserve everything as much as you can to do this efficiently. So the answer to that is to use asynchronous I/O. If you're used to BSD sockets, this is pretty weird stuff because everything is callback based. So you'll make a call to read where you'd expect that you block until you read something. It doesn't work that way. You call out to read, and then it continues on its merry way without waiting for any reply. And there's a callback method that you've registered previously that says, when something happens on that read, call back to this function and with the data, and then I'll do something. So you kind of have to turn inside out some of your thinking about how to handle communications like that, because nothing ever blocks, nothing ever waits, nothing ever stops. It's always just immediately going forward from any networking call, and you don't know until later if it failed or not. So that presents an interesting challenge. Then we have HTML5 WebSockets. You want HTML5 because the client is portable everywhere. The old way is to use Flash and to use regular sockets, and there's a little socket server trick that lets you serve this stuff up, so Flash will recognize the ordinary sockets as an IO connection. It's actually a Ruby script that does that. But with Flash, you have a lot of difficulty in making that work cross-platform. It can be done, but HTML5 from the get-go is designed to be cross-platform. It's JavaScript, but it doesn't talk sockets. It only talks WebSockets. So whatever socketing library you use, you have to have this extra layer of WebSockets on top of it, which is basically this extra protocol that makes a live socket connection look something like an HTTP connection. And then the last bullet on my slide was that's not really whether you're using SQL or NoSQL, that you want to have some sort of database connection that handles all this, because with hundreds of thousands of users on board, you need quite a database to keep track of everything that happens. And if you're playing money games, then there's a tremendous amount of accounting involved as well to make sure that nothing goes where it should not go. So the basis of these servers, I worked on a server for the Navy. Well, the military, the Navy and the Army. I was a Navy employee, but it was actually being built for the Army. But this system was a first-person shooter game where everything was mil-spec. Everything was realistic within the game. We had the actual Apache attack helicopter specs and the actual M1 Abrams tanks specs and things like that. And that actually used the same architecture. So it's been around a long time to have these packet-based game systems where basically everything is kept in state in the server, everything is kept in state in the client, and these packets are passed back and forth that are basically requests to do something. Like, I'm firing at these coordinates and sending that packet to the server, and the server is saying, okay, well, this object was destroyed, and sending the packet back, and then the client's saying, oh, well, okay, that object was destroyed, I have to update my screen and, blow up that aircraft or whatever it was. And so these packet passing systems have been the norm for a long time in these massively multiplayer online game systems. But it's a little more interesting when you get in for the further constraint, you want everything to be asynchronous and so forth. So I've already talked about that we've got to cope with the one-sided player. What we really don't want is one thread per player, which is why we can't be blocking I/O. Because if we were going to block, we would need to have another thread that wasn't blocked, and we would run out of threads. And then we'd also like to conserve RAM per player, but that's something that you want to do anyway. And then another thing that may not be obvious off the bat is you want to avoid lookups on every packet. That you could keep, and probably will keep actually, a table, a map that goes from socket IDs to the actual player object in memory so you can send the right packet to the right player and things like that. But you prefer not to look on every packet to do that because you could get into a fair amount of overhead doing that. So to avoid this, in asynchronous I/O, you'll actually try to map back to the individual object that is that side connection, so it goes straight to that, and you don't have to do a lookup. Thanks. Okay, so with packet processing, we're going to process each packet twice. The reason that we're processing it twice is, as I just mentioned, you have the callback that comes straight to the object because that's working, because that's more efficient. But you don't want to process that packet at the point that you take it off of the network. For one thing, there are all sorts of locking scenarios and things that probably aren't where you need them to be. And the other thing is you want to get off of your network I/O thread just as quickly as possible. You don't want to do a lot of processing there because you want to free up your network I/O to do something else. So you're going to unpack the packet enough that you know what the thing is, and then we're going to poke the this pointer, for those of us in C++, into the packet. Just have a null pointer sitting there. Then when we get the packet, we'll point this into it, so that when we put this on the message pump, when we pull it back out again, we've already got the this pointer and don't have to do a lookup that we would not like to do. So the way these packets are laid out, all the games pretty much work this way, at least the ones that I've worked on. There's a header that will have some sort of usually it has two codes. One, it has a major code and then a subcode. And so the major code can be like, this is a poker game and the person is playing. And within that, the subcode can say, and this person is making a bet, or this person is going to call, or this person is folding. All of the kind of subcategories of that type of play that you can think of. So we've unpacked the packet. We also have to unpack the packet body, which is various C++ types and things like that. This is just marshalling. We have to unmarshal the data, which is very common to anyone who's done COD programming and things like that. Okay, so in the network I/O thread, we've got the packet unpacked a little bit, so we know what the thing is. We're conveniently inside of our object already because we're clever about putting a callback to the object that this packet belongs to. So we're going to put this in the packet. Then we're going to push this onto a message queue that is going to do the real processing of this packet. We're not going to do anything with the packet except just unpack it at this point. And unless we have some custom data structure, we're going to have to put locks around this so that we don't smash up our message queue. So now we're done in the networking I/O, and this is just going on all the time, pushing these packets onto our message pump. So then over in the message pump thread, it's going to wake up. I didn't put the signal. I didn't know that we were doing a signal here, but obviously we've got to signal the pump to wake up when there's a new packet up. And again, we'll have to lock because now we're going to get the packet off the queue. We don't want to corrupt the queue during that. And then once we get the packet off, we can conveniently call this route. And since we're already inside our object, it just magically goes off and does everything that we want our object to do. It's fabulous C++ object-oriented programming that we're all familiar with. And as I mentioned before, if we want to do this lockless, which we really might, we're going to do some kind of custom container where we put things on one end and take them off the other in such a way that we don't step on our queue and cause queue corruption by having simultaneous operation. Actually, another server, but this server will run thousands of client sessions and mimic this exact same communications protocol that you would have if you had an interactive client. So you can do load testing of your server or to populate it with robotic players, whatever you want to do. And so it was very important to be able to have an architecture that worked with client and server, asynchronous, regular sockets, and web sockets. So we ended up with Boost ASIO and WebSocket PP, which turned out to be very nice. We're very pleased that we made that choice. So then going ahead to databases, we started out in MySQL, we migrated to a cluster to get better performance, of course. The nice thing about MySQL clusters is that you can develop just using plain old MySQL and change your mind later. It doesn't really show up in the database. And there is, when you create the tables, you have to say whether they're cluster tables or not. So there's one little tweak that you have to make in converting your data over. But stuff pretty much works, except that the cluster doesn't support foreign keys. So if you have foreign key dependencies in your data, you have to take those out in order to make it happy on the cluster. I think they're fixing that, or maybe they didn't fix that. I haven't kept track because we already took all the foreign keys out, so we don't care anymore. The cluster is more work to admin, but they've actually improved that quite a bit. I'm told that the next time that I go to install it, it won't be such a nightmare. And then a lot of places are going to NoSQL because it may scale better, and the things that you need to query for games typically are very SQL-ish. That you don't tend to do a lot of intricate joins and things like that. That you're basically just putting things in and taking them out, which NoSQL databases are very good at. Okay, so just to review how the platform is set up. The modern client is HTML5 JavaScript. We also have a legacy client that is Flash ActionScript, and these both talk the same protocol, except one is talking sockets and the other is talking WebSockets, because you only have WebSockets when you're in HTML5. Then the server is C++ with Boost, converted from what was originally 150,000 lines in Java code. I haven't actually put the code counter on it lately, but I think we're down to like 50,000 lines of code, even though we have much more functionality and much more error checking than we had when we started, just because we've been able to improve algorithmically a lot of things that were not coded in the most efficient way. Cut and paste can really make code a lot bigger than necessary. So, something I do that is sort of unique in this area is I develop on all platforms simultaneously. Most people pick a platform and stick with it. We picked FreeBSD when we started on this project for performance reasons. But in the meantime, Linux improved, and so now we're running on Linux. But I really prefer debugging with Windows. I like the Visual C++ debugger better. So I end up developing everything on Windows and then deploying it on Linux or FreeBSD or Windows 2 if people actually are crazy enough to want that on their server. The way that I do this is that I have a little library called Library Standard that I wrote that basically just connects up the POSIX bits of Windows with the same thing in Linux. Many people don't realize that the BSD sockets are actually natively supported in Windows, and the pieces that supporting that would imply you also supported. But they all have different names, and they have the right header files, and it's just, it's like, could they have made it difficult? It's like, all that functionality is there, except for time of day. Time of day is the only thing that's like absolutely missing from that. But time of day is actually quite trivial to write. So I built this little library that I stick on top of everything that I do, so that I can write everything Linux style. The only thing that is notable that this will not allow me to do is fork, but I don't want to fork anything, I want everything to be threaded, so that's no restriction at all. So I'm testing localhost on Windows. I've got MySQL running. I've got Visual C++ running. I've got the debugger one running. My little laptop is just going, and maybe some robots running to load up so I have some players to test against. And then I'll actually build in VirtualBox on my Windows box so that I don't have to upload source code to the web, so I can. It's more of a security thing. Like, maybe I don't want to have the source out on the web somewhere. And then I have this very kind of crazy auto-recursive make file that I invented. And what happened was as you recall, I inherited 150,000 lines of Java that were converted pretty much one-to-one file-wise to C++ originally. And so that resulted in like 1,000 files to compile. And I had no make file, because Java doesn't use make files. And so I was facing the prospect of a week of work creating, laboriously writing a beautiful make file. And we couldn't afford it. We didn't have a week to make a make file. And so I said, well, I'll call my friend who's a rocket scientist. Now I have a friend who's an actual rocket scientist. In fact, he's out launching his rocket this week. If I needed to call him for advice, I would not be able to reach him because he's launching his rocket this week. He's gone over to the commercial side. He's got a commercial rocket that he's launching this week. When I met him, he was the flight software engineer for Mars Pathfinder. So he's the first programmer to successfully land a spacecraft on Mars. So he's pretty good. When I have a problem that I feel like maybe I'm kind of stuck on, I'll call up my friend Steve and say, hey, I've got a problem for you.
Yeah, but he does the same. Sometimes he'll have a problem you just can't
Well,
get.
he'll sometimes call me, but the thing about Steve is he came up through the Jet Propulsion Laboratory culture, and he's done everything old school. I've come up in more of a non-traditional route. And so sometimes it's very interesting to see the take that he'll have on something that, you can go way back, if there's no modern solution. And that was actually what he did this time. He said, well, okay, so you need a huge complicated makefile, but you need it today. Okay, so Steve had actually never done this, but he thought it was hypothetically possible that you could write a makefile that would grind down through every subdirectory and just build everything in the directory. And then at the end, you could have this, not build any libraries, not archive anything, just grind down, and as it's grinding through all these directories, be moving the object files over into one directory, and then at the end, just do a big bang link, and you'd have your executable. And sure enough, that worked. So, and it's not a very, it has no dependency. So if you change something, you're out of luck. You need to build the whole thing unless it's like really small and you understand what to build yourself. But most of the time, because I'm building in Windows and testing everything in Windows, by the time I come to this point, I'm done. So I don't need, I've got to do a big bang build anyway. It doesn't gain me anything to have all the dependencies. So we're still using it. A year later, even though we were sure that we would take a week and really do the right engineering. It still works. It's good. So then take the executable up to Linux or FreeBSD, where I've installed it as a service, so I can do start and stop and all that good stuff on it. And that's the platform. Next.
Did it go? Oh, it didn't go.
I
hit it.
Oh, it's over. We're done. Oh. Back to America. Okay. So for those of you that want to do some further research, if you search on C10K on the web, there's all kinds of interesting literature about how to deal with the socket problem. People are now working on having 500,000 open sockets on a Linux box is the level that people are working on right now, so it keeps getting bigger and bigger. We're well past C10K. And then if you search on Boost ASIO, you'll learn about the Boost asynchronous I/O library, which is really cool. And it's a little crazy because it also offers synchronous I/O. And it's very confusing when you go to read the docs because it's like sometimes you're talking about synchronous and sometimes you're talking about asynchronous. And you're like, could you just pick one? I'm only going to do one at a time. And then WebSocket PP, which is pretty obscure. I had a harder time finding that because the WebSocket stuff is all brand new. There's a land rush right now to port things over to HTML5 because it's just become prevalent enough that it runs everywhere and is reliable and mostly works. And so it's the flavor of the month. So everyone's like chasing WebSockets as a result of that. And then HTML5, of course, there's all kinds of great literature on the web on that. Something I didn't get on my slide that I really want to give a shout out to is the Boost ASIO book. That's by John Tweecher, and it's fabulous. And you can download it off the internet and all that good stuff. The documentation on Boost ASIO on the web is not very tasty. It's really tough sledding. I would really recommend that you get the book in this particular case. Then, if anyone wants to buy one, get a standard thingy, I will send that to somebody. But most people are not inclined to develop on Windows for Linux, but I like it, and if anyone else wants to join me, I will help them do so. And there's my contact info.
And actually, before we really started, we forgot to ask how many are doing games, how many are thinking about
I
doing
didn't
games.
forget, we can do all that now. Let's research the audience.
We should have done it first, but let's do it now. So, how many people are developing games or thinking of doing a game server? No? Okay. Yay!